Okay, so the goal of this lab is to see how to build a content-based filter using only low-level TensorFlow operations. We're going to follow the technique that we described in the lecture. We'll start by importing the necessary libraries. In this example, we only need NumPy and TensorFlow, and we'll print out the version of TensorFlow just to make sure that we're working with 1.8, which we are, so that's great. In the next cell, we'll give names to our users, names for our movie titles and our features. And we'll set the variables for the number of each of these. Okay, moving on. In this example, we're going to assume that we only have 4 users, 6 movies, and 5 features. So recall that for a content-based filter, it's necessary to hand engineer the features that we're going to use to embed our movies and our users. Here, we're going to use the features of action, sci-fi, comedy, cartoon, and drama to create our 5-dimensional embedding space. In the next cell, we're going to initialize the inputs and define both the user item interaction matrix and the movie feature matrix. The variable users movies holds the user item interaction matrix, and each row corresponds to a user and each column corresponds to a movie. And the values indicate the ratings that each user gave for each movie. So for example, looking at the first row, this corresponds to Ryan's ratings for the movies. It looks like Ryan gave a rating of 4 out of 10 for Star Wars, a rating of 6 out of 10 for The Dark Knight, and a rating of 8 out of 10 for Shrek. And the zeros in the remaining elements of the row indicate that Ryan hasn't seen or hasn't rated the other movies, so it has given no ratings for The Incredibles, Blue, or Memento. And the same is true for each row after that. The variable movies features here holds the k-hot encoding of the features for each movie. So in this matrix, each row represents a movie and each column represents a feature. So for example, for our first movie, Star Wars, the series of zeros and ones in this row indicate that Star Wars is encoded as having action, sci-fi, no comedy, no cartoon, and some drama. So since we'll be doing these computations in TensorFlow, this next block of code is just to take the variables that we set above and store them as TensorFlow constants. Now we come to our first to-do. The goal here is to create the users, movies, features tensor that we discussed in the lecture. So this is going to be made by stacking together the weighted features matrices for each user. What we'll want to do is to compute the weighted feature matrix for each user, store all of those as a list, and then we can stack them together using the TF stack operation. So let's do that now. So in code, we can create a list of this product for each user using a list comprehension. So I'll start my list comprehension in this way. I'll be multiplying each row of the user's movies matrix to the values in the movies features matrix. So I'll take the users movies matrix. I'll want to take the transpose of that. I can do that using TF transpose here. To take one row, I'll slice this out. After taking the transpose, I'll slice it out by taking all the rows and just the ith column. And then I'll multiply that by the movies features matrix. And I want to do this for every user. So to create in my list comprehension, I'll do this for all the i's in the range from 0 to the number of users that I have. So in order for this broadcast multiplication to work, we also need to expand the dimensions of the user's movies tensor in the first axis. So this computation itself wouldn't work out on its own, so what we'll need to do is use a TF expand dimensions of our transpose of the user's movies matrix, and we'll specify the axis to be equal to 1. So now what this will do is it'll create a list, which is going to be the weighted feature matrix for every user in our database. Next, what we'll do is we'll stack together these weighted feature matrices to create our total user movies features tensor. So in TensorFlow, the way that would look is we can just do a TF stack on the weighted feature matrices that we computed just above. Okay. The last step is to normalize this users, movies, features tensor against the movies dimension so that the components all sum to 1. This is done by summing across the movies dimension in that tensor we created above and then normalizing with the total values. So those two values are computed here. Users, movies, features sums against the movies dimension. So to do that, we're using a TF reduced sum. Here we're specifying the axis to be equal to 1 because that's the axis for our movies. And our users, movies, features totals, then we'll do another reduced sum, which is then going to sum for each user the sum of all the feature values. Okay, so next what we want to do is normalize this tensor for each user, and we can do that using a list comprehension. So I'll set up my list. We'll take the users, movies, features sums for each user, and we'll divide by the users, movies, features totals for each user, and we'll do this for every I in the range from 0 to the number of our users. This is going to create a list that has the user feature vector for every user in our database. And so the last thing we want to do is stack these tensors together to create a single matrix for all of our user feature vectors. So like before, we'll use a TF stack, and we'll set our axis to be equal to 0. So the resulting users features matrix that we just created is a collection of all the user feature vectors for each of the 4 users that we have. Given this, we can look back and interpret the feature relevance for each user. And we're going to do this with the following helper function. So you can see that here. So let's read through what this function does. So this function finds user top features, takes as input a user index, and what it returns are the top features for that given user. So to do that, we're using this top k function in TensorFlow. And what we'll pass are the user's features that we created above for that user, and we're going to ask it to return the top 5 features for each user. The last element of this function then is to use TF gather in D, and what this does is it takes our features, right, a list of our features, and it just evaluates the top indices for that given user. If we actually want to evaluate what these variables are equal to, since we're working in TensorFlow, we need to create a TensorFlow session. So that's what we do in the following cell. So we create our TensorFlow session here, and we initialize our global variables. We're going to create this empty dictionary called users top features, and what we'll do in the following for loop is just propagate that dictionary, where each key will correspond to a user, and each value of that key will correspond to that user's top features. So you can see that what's happening here, the top features, it will evaluate in the session the find user's top features for that single user. And to propagate the dictionary, we're going to set the key to be equal to that user, and the value will be the list that we return that we're calling top features. Okay, so this next cell, we can look and see what our user's top features look like. So looking at the first example, we see that for Chris, the most important features for him would be action, then sci-fi, then drama, then comedies, then cartoons. And the same for all the other users in our database. Okay, so in this last section, what we're going to do is we're going to use that users features tensor to determine our movie recommendations for each of our users. To do this, we'll need to compute the similarity measure between each user and each movie. We'll use a dot product as our similarity measure. Since we want to compute the dot product between a given user feature vector and every movie in our database, we can use a map function. So that's where we come to this to do here. It actually gives us a hint telling us we can use a TF map function. And what it does is it applies some given lambda function to a list of tensors. And since we're taking the dot product as our similarity measure, the operation we want to use is a TF tensor dot. So to fill this out, what we'll do is we'll take TF map function. We'll set up our lambda function. And what this will do is it'll compute the dot product, so TF tensor dot, between our user's features tensor for each user. I'll set up here x because it'll be taking a dot product of that vector with the movie features vector. We'll set the axes equal to 1, since we're taking a dot product using tensor dot. And then we specify what we want to iterate this lambda function over, and we're multiplying through the movies features vector. So I set that up here. This will compute the user ratings for a single user. So as before, I'm going to wrap this in a list comprehension. And I want to do this, again, for all the i's in the range from 0 to the number of users that we have. This last part of the cell just says, once you have that list of all the users' ratings, stack them together to get a single tensor called all users' ratings. Okay, so moving on, as we mentioned in the lecture, to make movie recommendations, we don't want to bother with movies that the user has already seen. So we're going to create a mask so that we can ignore the previously rated movies. We can do that using tf_where. So just to remind you, the way tf works is by specifying a Boolean condition. When the condition is true, we take the first value, and when the condition is false, we take the second. So here's our Boolean condition, this tf equal. We're going to see where is our user's movies tensor equal to 0. And when it is equal to 0, we're going to use the all users ratings. And when it's not equal to 0, we're going to set it to be equal to -infinity, just so we can completely ignore it. To find the top movie recommendations for each user, we'll use a similar helper function to the one we saw above. The function here, find user top movies, takes two inputs. It takes the user index and the number of movies to recommend. And it does two things. So first, it determines the movie's index, right? So these are the indices of the top movies for a single user. So we're using the top k function as before. As input, we're giving it the all users ratings new matrix that we created above, which is just our user ratings for all of our users, but masking out the movies a user has already rated. And we're passing the number of movies to recommend. This could change for certain users because users have seen different numbers of movies. At the end, we just return the movies for each given user. So again, to do that, we'll use this gather ind operation. We pass in our movies list, and we say evaluate it at the indices that we found above. So as before, in order to evaluate these values, we need to create a TensorFlow session. We'll initialize our global values using tf global variables initializer, then create an empty dictionary called user top movies. And what we'll do in this next for loop is to propagate that dictionary, again, using the users as keys, and then now the values will be a list of their top movies. So for each user, we want to figure out how many movies to recommend. And to do that, we'll create this variable called number to recommend. And it's just going to be done by taking a reduced sum on the user's movies matrix and figuring out how many times there are zeros for each user. The for loop will then iterate through each of our users, and it will collect the top movies using our find user top movies function above, and then add to our dictionary the key, which is the user, and the value, which is the list of the movies for that user. We can then examine what this dictionary looks like and see what the movie recommendations would be for any one of our users. So for example, for Danielle, we see that for her, we'd likely want to recommend The Incredibles first, Star Wars second, and The Dark Knight third.